Good afternoon, everybody. Welcome to Tippett's Physics. What is crappening? Today, we are going to look at combined series and parallel circuits. So we're going to look at practice problem number 12. And although it's a blank page, we're just going to draw a circuit together. So we're going to have a 6-volt battery. And we're going to the left, up, and we're going to run into resistor 1. And after resistor 1, it's going to branch into two parallel resistors. So we'll call one R2 and the other one R3. And then these will all combine back to the negative end of the battery. So we have a 4 ohm resistor. We'll call that R1. A 5 ohm resistor. 5.0 ohm, sorry. We'll call that R2. And a 9.0 ohm resistor, we'll call that R3. So what we're going to do is make a VERP diagram like we have in the previous problems, except this time we're going to include, since we have a parallel branch, we're going to call that 2, 3. We'll copy and paste our VERP diagram. Except again, this time we're going to include resistor 2, 3 since those are in parallel with each other. So why don't we start off by writing what we're given in this problem. We know that we have a 6-volt battery, and we know the value of each resistor. So, excuse me. And we know the value of each resistor. So R1 is 4 ohms, R2 is 5 ohms, R3 is 9 ohms. And that's all we're given in this problem. So we do have to come up with a plan of action. Vermont Maple Tea. We do have to come up with a plan of action based on the given information. And what we can see is since R2, 3 are in parallel with each other, we can calculate their equivalent resistance. So first we're going to calculate R23. And to do that, we're going to do 1 over R23, because they're in parallel, is equal to 1 over R2 plus 1 over R3. So we have 1 over R23 is 1 over 5 ohms plus 1 over 9 ohms. That's going to give us 1 over R23 is equal to 14 over 45 ohms. Which means R23 is 45 over 14 ohms. And if we put that in a decimal, we get about 3.2 ohms for R23. We can also see in this problem that if we want, we can calculate the equivalent resistance of the circuit. And to calculate the equivalent resistance, we can see that we have R1, which we know is 4 ohms, but we also know that R23, their combined resistance is 3.2 ohms. So if we want to calculate R123, we could do R1 plus R23, because those are in parallel and we calculated their equivalent resistance. So we get R123 to equal 4 ohms. Plus 3.2 ohms, and we get 7.2 ohms. So now we can look at our next plan of action. We could see that we have the total potential difference, the total resistance. So if we want, we can next calculate the total currents. And we know from Ohm's law, I total is equal to V total over Req. So that gives us 6 volts over 7.2 ohms. And we get 0.83 amps. So our total current for the circuit is 0.83 amps. So now we can look at our circuit. If we follow the path of the currents, we know that the total current goes through I1. And then we also know that it splits off, so we call this I total. Then it splits off into I2 into I3. So right away, the first thing that we could say is that I total is equal to I1. And that gives us 0.83 amps. Oops. 0.83 amps. We also know that I2 and I3, because 0.83 amps from I total splits off in I2 and I3, they're going to recombine, and I23 also equals 0.83 amps due to the branch. So we could see that we have a few currents that we don't know, the ones through I2 and I3, and we also don't know the potential differences. So why don't we look at the potential differences? I'll call this step 5. So since we know our currents and resistors, we could find V1. We'll use Ohm's law. V1 is equal to I1 R1. So V1 is 0.83 amps times resistor 1, 4.0 ohms, and that's going to give us 3.32 volts. We could do the same for I23, so 0.83 amps times 3.2 ohms. That gives us 2.66 volts. Because R2 and R3 are in parallel with each other, we could use our rules of parallel circuits to calculate their potential difference. And we know that the potential difference across R2 is equal to the potential difference across R3, which is equal to the potential difference across R23, or the total potential difference for those two resistors. So we could say that V23 is equal to V2, which equals V3, which equals 2.66 volts. So 2.66, 2.66. And then lastly, we could calculate the current that flows through R2 and R3. We'll call this step 7. So why don't we show our work for I2? That's equal to V2 over R2 D2. If we plug in chug, it's 2.66 volts over 5.0 ohms. In our calculators, we get 0.54 amps. If we do the same for R3, we get 0.3 amps. Hopefully, if our math is correct, that we know that the sum of the currents of the individual resistors in parallel equals the total current. So 0.54 amps plus 0.30 amps should equal 0.83 amps. Based on the rounding, it's not going to be exact, so if we cut this as fractions, we'd get a more precise answer. So we're going to skip the power for now, because we know how to do that. We're experts. It's just P equals V times I. Next video, we're going to look at a different method of analyzing the same circuit, using what's called Keir. Let me get a cough drop. It's called Kirchhoff's rules. If you like this video, please like and subscribe, and I'll see you next time. See ya.